All right, so in this video, I'm going to go through some of the things that I noticed during exam 2 that I think many students can improve on. In some cases, they're kind of isolated instances, but I think they're worth bringing up just to make sure that other students don't repeat the same mistake. We have 2 exams left, so we want to make sure and learn and do better. So anyway, here we go. First, and I talked about this before, but apparently some students aren't listening and internalizing this. You can't throw out an abbreviation in your explanation unless you tell me what it is. Remember, the ultimate goal is you're explaining the data to somebody else. And if you tell me that CR was greater than AL, that means absolutely nothing, because who knows what CR and AL are? Nobody, except you, because you read the paper. And I'm not even sure you know, because you didn't tell me. So you have to know what these abbreviations mean, and you have to explain them. Right? Just don't throw out an abbreviation. It costs points, even if everything else is correct. Right? So that's number 1 here. And by the way, these are in no specific order. So you'll see kind of a smattering here. Having too much information, and I combined this with incorrect information. For instance, too much information, if you're explaining the figure and you talk about, the measurement Z is greater in X than it is in Y, that's all fine and dandy. But then you go on to say that this means that da 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 da. Well, I'm asking you to tell me the data, not explain what it means. And that's additional information that you don't need to provide. That's information that you don't get from the figure itself, only from the paper and the interpretation of the figure and how it applies. Okay? That's not a horrible thing, but it goes beyond describing the data. Akin to that is having, well, let me tell you a few more things, or information that is not in the figure. You start to tell me about information from other figures too. Well, now you're not explaining this figure to me anymore. And that tells me you don't know what is in that figure. Because you're also telling me about the figure next door and the figure below. And, in their explanation, they might be combining things together, right? And if you only go to the figure legend, you're missing the entire point, because the figure legend is to help you understand the figure. It doesn't explain the data at all. Okay? And that is also incorrect information, because it's not right. If you're giving me a figure and you're talking about body weight in 2 different types of mice, and then you also start to discuss skeletal muscle mass and fat mass, but this figure only shows body weight, you're wrong, right? You're wrong, because you're not telling me only the figure. Don't tell me about other things. Tell me only about that figure, right? So here it says stick only to the data in that specific figure. That means you have to know it. You have to know it. And if you're not spending time in advance to know these figures and you're trying to figure them out during the exam, it's too late. Right? It's too late, because now you're going to spend a lot of time taking the exam trying to pull information out that you could have spent. It's the same way in a class where you're being tested on material, and if you don't look at that material until the exam time, you're cramming, and it doesn't work very well, especially for long-term memory. Oh, these are so easy to grade, but I still don't like them. If you leave an answer blank, there's nothing I can do to give you points whatsoever. For every single question, I have a rubric. And if you at least get some of the things in that rubric, I can give you points. If you leave it blank, I can give you nothing, right? And I'd much rather see you try to get some points. These questions, again, if you haven't looked at these papers in advance, if you really haven't spent sufficient time with them, and annotations itself is something that I'm looking at, but only you know if you have really really dug into that paper, right? The annotations, that's kind of my indicator, but it's not a perfect indicator, but you know. So make sure you do that so you can answer these questions and give yourself enough time. By the way, I saw an email from a student last exam. By the way, I heard that you were considering extending the time in the exam. I do not know where in heck that information came from. I was never considering extending the exam. A student asked if I would. That's not the same thing. And unless you heard it from me, you've heard nothing, right? Do not depend upon other students. They don't know what they're talking about, right? If you have questions, you go to the professor. If I was going to extend the exam, I would have let you know. And I'm not. You have sufficient time for the exam. Okay? So anyway, just remember, if you don't have enough time, if you left it until the last minute, you know you can't get these questions done, and you will have to leave some blank. When you are explaining the key data for a paper, and you're providing the justification. Now, thus far, I've given half of the credit for the key data and half of the credit for the justification. Because the justification is the main part. On future exams, as we progress, I'm going to weigh that part more heavily. And one of the common mistakes I'm seeing with justifications is that it's circular. And what I mean by that is that you're saying, these are the key data because they are important, or because these are the key data. These key data that show muscle mass is different in these two lines of mice are important because they show that muscle mass is different in these two lines of mice. What the heck? Right? You can't say things like that. Why it's important is because this helps us to better understand this process. Or if we put this figure and this figure together, that illustrates the importance of insulin in suppressing ketogenesis, right? Maybe the figures didn't directly show that insulin suppresses ketogenesis, but by combining things together, we are able to show that. That's the idea. Some students are going back and saying that the main aim of the paper was for the authors to show right? This was the aim. They wanted to do this. This was their hypothesis. This figure and this figure right here are the figures that really provide the evidence for that hypothesis. Right? That's valid too. But what you can't do is say the data are important because the data are important, or because the data that show X are important because they show X, right? You're not thinking deeply enough in that situation. So make sure and have a good justification for your key data. And we'll have another one on key data later on. This is still a common issue where I'm getting some descriptions of the figure and not of the data. And there's two different ways that this is done. One is they're explaining the entire experiment. This group was treated like this group was treated like this, and they measured this, and that's where they leave it. Well, that's a problem because you never, we'll talk about it later on, that's a lot of the information about the figure and about the experiment, but not the data. In fact, I probably should have covered that in a later slide. What I really wanted to talk about here is that students start to explain and describe the figure, what the bars are like, that there's air bars, that there's an asterisk, that the y-axis is labeled this, that the x-axis is labeled this. You're not trying to build a picture of the figure in somebody's head. You're trying to describe the data, and none of that has anything, it has to do with you looking at it and understanding the data, but it doesn't have anything to do with you explaining the data, which is what you're supposed to be doing. And I gave two examples here. These aren't real. These are things that I made up, but these are, very close to what many students have put. So in this case, I put group HF, which ate an 80% fat diet. That's great, right? Good description of group HF, high fat. Had higher organ damage than group LF, which ate a 30% fat diet. Right? We have everything we need. We have the groups, we have their diet, which was the intervention, the thing that differed, how it differed, and the one group is greater than the other. That's great. But what I'm seeing is what might happen in the second instance here, where it says not good. Oh, here we go. Lost my cursor. I tend to do that. So now the black bar. You're explaining this. Nobody can see it. Nobody cares if there's a black bar. We care what the data are, not what the bars are like, right? The black bar shows group HF had organ damage of around about 112 units of the big error bar. Seriously, I'm getting explanations like this. You're trying to be very precise with your explanation, which I appreciate, but it is not necessary. What we want to know is what are the differences? What are the differences? Just be very clear about it. Like in the first example here, right? That's very clear. All right, then we start to explain other things in the figure. There's a dashed line. Okay, but what does it mean? Right? Why is there a dashed line? What does that mean? And then we've got a white bar for group LF, and it has organ damage of 62 units. Now this student, if they put something like this, does not lose all points, right? We do have that group HF is 112 and group LF is 62, and so we can see that one is group HF is much higher than the other one, right? And we have that they're measuring organ damage. So this is not absolutely horrible, but there's so much explanation here that it's unnecessary. And where is it? This is the abbreviation thing, right? What is group HF? What is group LF? You have never explained it. And so somebody listening doesn't know what it is. And now when they're following this, they're trying to get all these numbers instead of comparing the numbers. Remember, the comparison is the most important point. You have to have all of the other information so you know what you're comparing, you know what the groups are, you know what's being measured, and all of those things. But in the end, you have to know what the differences are between the groups. And here, yeah, the data are listed, but the differences aren't spelled out clearly. Okay? So again, describing the figure, not the data. This is what I was alluding to earlier, where the description actually described the experiment. But then the differences between the groups are lacking. So the example here, and this is the bad example, the figure shows how MC4R double negative mice and the MC4R double positive, and we could say, homozygous knockout or homozygous, MC4R. There's different ways to say it, and I don't make you spell out like MC4R, things that we're really focused on. I haven't done that, but like measurements and groups and things I do. But anyway, remember these were in, and were compared. The figure shows how these two different groups of mice gained weight over 32 weeks. Indeed, the figure does show that, except this explanation does not explain how one group differed from the other group. And you can't just say, and another mistake I see sometimes is they were different. They were different is extremely vague. Which group was higher? Which group was lower? Right? This is what we're looking for. And remember, ideally, we try to compare to the control group. So we would say, in this case, the control group is the MC4R double positive. And so we say the MC4R double negative mice gained weight at a faster rate than MC4R double positive mice, right? Because, so the higher one, again, we're not saying the control is lower. We wouldn't know. The treatment group that is higher. Anyway, another mistake, by the way, I didn't put this in the slides, but I'll include this, is that some students didn't include this part here. They only put MC4R. And that really left me wondering. Or students only put negative, negative, and positive, positive. Well, what gene are we talking about here? I'm okay with that notation because that's a standard genetics notation that people should be able to understand, but it refers to a gene. What gene is it? And we have to know that or we can't understand the data. This is a little bit of a pet peeve. Why would you misspell a word that you're copying directly out of an article? Think about it. And again, I encourage you never, ever, 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 ever to do this on your phone. Don't do these assignments. Don't do these exams on your phone. That's what you're doing when you're not taking the time necessary to really get through this. Misspelled words are a no-no. But this isn't it's not an in-class exam where you're writing things off the top of your head. This is the words sitting in front of you on a paper and you can't even copy it right. That's a problem, right? That indicates to me that you are not looking at this carefully. And if it's the wrong word, if you just miss a letter or something, right, and it's clear, I'm not taking up points for that. But if it's the wrong word, and I have seen this where it actually turns out to be the wrong word, it's the wrong word, even though you meant something else, right? This is a senior biology class, and you have to say what you mean. You can't say, well, that's what I meant. No, those days are done, right? You don't get to do that in a 4,000 level class. All right, good opportunity to talk about this a little bit. I have had more than one instance this semester where students have shared answers with other students. One of the rules of the exam is you do not do that. And I know that it has happened because these students got burned. They thought they were helping somebody. Hey, here's how I did it. And thought maybe it would help somebody else. Don't do it. First of all, remember, that's against the rules. Don't break the rules. There are consequences for breaking the rules. And the other students turned around and put that answer on their paper. And nobody gets credit. When that happens, nobody gets credit because both students broke the rule. And the students who are copying are going to, that is an integrity violation, and I will report it. So you have to know this, right? You can't do that. Just keep your answers to your doggone self. You're not helping anybody else, and you might be setting yourself up to go up in flames. Okay? And again, just don't do it. If you have questions, direct them to me. If you're waiting until the last moment, it's too late, right? If this is due on a Friday night and you're working on 11 p.m., I go to bed at 9. I'm an early retirer. On a Friday night, I might actually watch a show with my wife till 10. That's late. I'm exhausted. I'm going to bed because I get up early, right? I am not staying up late waiting for student emails. So you want to make sure and get that information communicated early if you have questions. Right, I had this happen a number of times. Well, this figure, this could be in the justification, it could be on the explanation of the data, but it talks about, hey, this is what's happening in humans. What? This is an animal study or a cell culture study, neither of which is in humans, and they are not directly applicable to humans. It gives insight into processes that we would need to subsequently, take a look at in humans, or maybe this is the best we can do to understand it, and we hope to high heavens that this is happening maybe in the same way, but it is not showing what happens in humans. It's an animal study. It's a model. It's a cell culture study. It's a model. And don't say you, as you can see. Well, first of all, that's not appropriate scientific language. That's a different topic. But this is what happens to you. No, it's not what happens to me. It's what happens to these animals in the experiment, right? It's the same problem. It is not what happens to me. We don't know that. And this is science. And this is a problem in science. Don't get me wrong, where people try to make their results more than they actually are. And the media is particularly bad at this. I even have my own examples from, in fact, I'll tell the story in class about my first paper. But anyway, This is not showing what happens in humans. That's getting beyond what the data in the figure shows. It's getting beyond what the key data in the paper even show. Some of the answers I read, and I don't mean to offend anybody, but are pure gibberish. I can't understand them. I can start to look for things that I'm looking for and try and figure out if it's being explained right. But I'm sorry, if your writing is completely unclear, don't expect me to be able to interpret it. I do not have a Urim and Thummim. It is not one of my spiritual gifts. I do not interpret bad writing. And I encourage you to go back and reread. And if you read it out loud and it makes absolutely no sense to you, it's not going to make any sense to me either, right? Because you're the one that wrote it and you didn't understand it. So please, please, please just double check. I'm not looking for perfection. This is not a writing assignment, but it's an exam and you have to communicate your answers clearly. And one of the main problems is sometimes I think students don't know what the answer is. And goes back to spending time with the paper. And if you haven't done that, you should have been. Right? The exam is too late to do that. Writing a few notes in the margins, glancing at a little bit is horribly insufficient and won't pass the class. Right? It takes significant effort to be able to do this. So please just look over your answers. The clearer they are, and the clearer that information is communicated, the more likely you are to get some of those points. Occasionally I have a question where it says, okay, so why did they do this particular experiment? Now, in general, it's because whatever they're looking at is related to what they're talking about and is part of the story, right? And I know that's really not an answer that you can put down as part of the story, right? Because you're going to have to be clear, what role does this play in the story? Why did they make this measurement? And the problem is, for instance, they measured leptin levels in muscle. And students will say they did this experiment because they wanted to find out what leptin levels in muscle were. No kidding! No kidding! That's circular reasoning. That's not an answer. And you can't do that. Why did they want to measure leptin levels in muscle? Not to find out what they were. They wanted to find out what they were because of a reason. And you have to go back and find the reason. Sometimes it's clear right in the writing of the text. Maybe not in the figure legend and probably not in the figure legend, but in the text. And it will explain that. And you have to, again, hopefully you've been through this ahead of time and not trying to go through it during the exam. And so sometimes, again, those reasons are clear in the text. Other times it's because the previous figure showed this, which suggested maybe this is involved. And so now they're measuring leptin levels in muscle. You know, there's a variety. There's not just one answer, but what I'm telling you is you have to think more deeply. It can't be they're measuring X because they want to know what X is. That's a circular answer, okay? I have some students struggling to choose key data. First of all, you need to be specific. I don't want the data that showed, in fact, I'm going to probably ask that you report the figure, the panels, and everything, as well as, talk about the data and why it's important. But I have some students picking like 6 or 7 figures. That's too many. Or a few students have even said all of the figures are the key. No. If they're all key, nothing's key. If we're all special, then nobody's special, if you know that line from The Incredibles. You have to pick specific data that shows specific things and then justify why that is the key data. So you can't use the ton of different figures. I'm okay with you picking across figures, different panels. I'm okay with several panels within a figure. I'm okay with one specific panel, as long as you're justifying your response. But it can't be random. It's like, oh, I'm going to pick this one, and this one, and then I'm sitting here going, what's the relationship? and you never told me what the relationship is, you can't get points for that. Another thing that's happening is a few students are summarizing the paper. Summarizing the paper is not describing the key data. Those are not the same question. The key data might be in a summary of the paper, but it is not a summary of the paper, and it is not a justification of the key data, which is what these questions are about. These should be the questions that are easiest to get the points. I'm not saying they're easy questions. They do take some thought and some effort. But when you do that sincerely, you're far more likely to get all the points. Okay? So you want to make sure and put in the time into these particular questions. Right, now I'm almost done. In fact, that's the last slide. I hope this has been somewhat helpful. I know it's gone almost half an hour, but I think, especially for students who want to improve their grade, it is well worth your while to watch this and apply this. And some students are just trying to improve a little bit more. And again, these are some of the things that you can look at to try to improve.